Thank you very much. My name is Brian Chamberlain. I work for Carlisle Construction Materials, and a lot of people ask me, how long have you been in this business? And I like to say that when I started, I was single and had dark hair. And now I have 4 kids. They've all moved out, and I have a 2-year-old granddaughter. So I've been in this business for a long time, and it's always been on the technical side. And the last 15 years or so, I've been heavily involved with the industry associations like IBAC, had written papers and presented to them. I work for SPRY, the single-ply roofing industry, and other organizations to make sure that we're constantly keeping up. I also work heavily with the code and action group that we have with SPRY, trying to basically develop code language to make it easier for roofing systems to be installed with less confusion. So there's a lot of stuff that goes on in the code. And one of the things that the code is always trying to do is sort of address some of the things that you guys have already been discussing here, this convention, such as resiliency, durability, making sure the system stays in, associated wind, and those kind of things. But the thing that glues it all together is actually the installation. We can write a bunch of words, draw a lot of details, but it really comes down to installing the roof correctly. And this presentation is about some of those issues. And the reason that we have it here is that the whole purpose is that we want to be able to make roofing material, have it specified, have it installed, and then we go on to the next job. And nobody come back to the previous job and have to deal with any kind of issue. So as long as we do all these steps, we're going to be able to make sure that we're all doing it correctly. So some of the things we're going to look at is learn how to identify the causes of air filtration into the roofing system and the possible results. Learn methods to enhance the long-term performance of the single-ply roofing system. Recognize the importance of pre-construction meetings and installation monitoring to provide successful installation. Understand the importance of perimeter securement and metal edge systems. Now, a lot of this stuff has already been talked about, but one of the things that actually keeps metalwork in place is going to be the wood nailers, the ones that we secure around the perimeter edge to make sure that we don't end up having with these kinds of issues. And they have to be investigated, especially in re-roof type of applications. If the wood is rotted and has problems, it's not going to stay in place. If we reuse it, it has to be replaced with new to extend that extendability. And the last thing we want is to have our roofing material look like a banner on the side of a building, waving in the wind to the customers and the people that go by. It doesn't tell a good story at all. There are some stuff like using nails instead of screws, and that's bad. Because nails go in really nicely. They go in straight, they go in fast. Unfortunately, it doesn't take a lot of work or effort to make those nails come back out. They come out just as easily. So we need to, when we're securing wood nailers, to make sure that we're securing them with screws to make sure that they're tightly in place to be able to withstand the wind resistance. There's a document that's out there. There's a lot of standards that can be used. This one is from FM. It's the Factory Mutual Property Loss Prevention Data Sheet 1-49. And it gives directions on how to install wood nailers to make sure they stay in place associated to the wind, give it the long-term durability. Right now in the industry, this is the strongest one that's being used. There are a couple of other ones that are minorly understood, but this is the primary one. This is for steel deck application. We're looking for 2 rows of fasteners staggered at 12 inches on center. But as we've discussed already in a couple of other presentations, wind resistance has different areas on a roof, such as the field, the perimeter, and the corners. So when they fasten and gets closer to the corners, they double the fasteners to actually compensate for that additional pressure in those corners to make sure they resist the wind. So these are some of the things to keep in mind. Review the existing conditions, specify screws, and try to follow the FM 149 or talk with your manufacturer to see what the guidelines are or your consultant to make sure that these are all correctly followed properly. Then the metal edging goes on. Now, back in the US, we're finding that approximately a building roof system costs about 10% of the building out of the whole structure. And out of that 10% cost, only 1% of it is actually the metal edging, the edging that holds the roof system in place. 60% of the litigations that we have and 60% of the warranty problems that we have is associated to wind and associated to the metal edging. So this is one of the biggest issues out there in performance-wise versus the roof system, and needs to be enhanced accordingly to make sure that it's installed correctly. So wind will fly over. In this picture down here, they did something that was right. They put a collet in there to help make sure that the fascia stays down. What they did wrong was it wasn't continuous. They stopped. If they had continued, that fascia would stay in place, would never gotten the wind underneath it, catching it, bended upwards, causing a problem. These are some other conditions where they didn't use continuous cleat, though I do like to point out that this particular one has got a ethos or a drive-it type of material. It's not really structural to start with, so that's another thing to sort of look at when you're trying to install properly. Make sure the materials are compatible and that there's actually structural interface when you're using fasteners and screws. In this case, the wind hit the fascia of the building, came upward, grabbed the metalwork, and started peeling it free. Best case scenario, roof system starts to roll itself up for re-roofing, make it easier for tear off. Not what you want, though. And these are some comments that came from Factory Mutual. When the lower edge of the fascia is not secured by a hook strip cleat, the flashing can be bent outward and upward, exposing more to its area to the wind's effect. Resulting prying action and uplift forces may rip off metal and or the wood nailers, including then possibly a catastrophic roof failure at that point. To be able to make sure that the metalwork meets this criteria, there's a standard ANSI SPRY FM 4435/ES1, or better known as just ES1. In this document, we are now to be able to test metalwork to meet the pressures associated to it. And this can be done with either prefabricated metalwork or actually shop fabricated metalwork. The difficulty with shop fabricated metalwork is that it needs to be trained properly, following the correct guidelines, bending it properly, correct gauge, and then, of course, securing it the same way. So it needs to be all followed properly. This is the testing parameter that we use, where we have all these RE1, RE2, and RE3. RE1 is used for mechanically fastened and ballasted systems because the membrane behind is loose. RE2 is usually used for all systems, where you have the force being pulled on it, the outside, and then RE3 is for coping caps. This is just showing a close-up picture. You have to imagine that this is actually the fascia of the building. This is the roof surface. And so they have the sample piece, they put a bar on it, and they start pulling on it. And they keep increasing that pressure till it pops off and fails. And that's where we get it popping off the cleat. This one failed at 90 pounds per square foot. I do apologize. I did not have time to convert this into metric, so, but you're all smart here. You're all kind of like engineers. I figured you could figure it out. This is a pre-manufactured. This has already been tested in the laboratory. This one actually has 242 pounds per square foot, a significant better uplift performance in this application, and easier for installation. And the only training you have to do for your guys is basically show them how it's installed. Some additional benefits: get high uplift. The product is sustainable and reusable. These products can actually be taken off and then reused on the job again. I've also found a personal benefit where they have this fascia cover. It's separate from the actual waterproofing or watertight condition. Say if a ladder hits this and damages it, it's easier to pop it off and replace it without ever having to affect any kind of flashing material or watertight integrity of the system. So keep that in mind. Cost is a big deal. Replacing the roof is a big deal. and it doesn't cost very much to put a proper metalwork that meets the ES1, be it prefabricated or shop fabricated. Reducing that criteria. The biggest thing is remembering that continuous cleat. Internal and external air pressure, a lot of this is external pressure we deal with a lot, but internal pressure a lot of times is sort of ignored because that's supposedly been addressed somehow in the engineering. Unfortunately, there are certain factors that come in that make effective the roofing system that is unexpected. This is just sort of a little bit poor construction where there was actually an opening within the metalwork, so the wind just pumped right into the roof system, weakening its wind performance. In this case, there was a gap underneath because of the corrugation of the metal wall went under this capping, and that air pressure moved itself in. In this design, this is a parapet wall, and below they did not seal this parapet open cavity, so all the hot, humid air from the interior of the building migrated into this wall, found a place to condense and condensate, and it caused rotting and mold problems where they started having issues. And this is just a close-up seeing how big that gap actually is. Since they didn't seal it up, it just allowed a lot of pressure to build up into it. This is a 4-inch wide gap, and they got 5.3 miles per hour wind coming from that. So a significant amount of wind force being presented by pumping that directly into the roof assembly and weakening its performance long-term wise. This one actually has an air barrier that failed, and that's the air pressure that's coming out from inside that building. And that, since that failed off that wall, and since this is the primary waterproofing membrane right along there, all that went right into the roof system. And whatever was carrying it, if it was hot, humid air, or just air pressure, it started to weaken the system. And this is what it might look like. Very active HVAC units, internal pressure within the building, and this is a mechanically fastened system, so these membrane will continually bellow with this kind of additional pressure. It's not going to weaken the rating associated with it, but it could fatigue the membrane long-term wise and cause some problems. So we want to control that so we don't have that type of pressure. There was a project that I had actually in Philadelphia, Pennsylvania, and what they had is they had an adhered system put into membrane. Membrane was adhered to the insulation, and the internal pressure was so great that the membrane popped off. Well, they came back and they tried to reapply the membrane, and it popped off again because still the internal pressure was so great the adhesives could not cure up. They did a lot of searching and they found out that this was a 60-story building, and all the air pressure was building up as it stacks up and throughout the building. So when it got to that point, they found a hole that was actually pumping air into that space. Once they closed that off, they were able to finally repair the roof. But that took 6 months of investigation to find out. So it's very important that if we're dealing with trying to minimize kind of wind performance issues, is to isolate the system from the interior pressure. If it's unknown, it's always a good idea just to seal the penetrations at the deck level, seal the joints between the deck to walls. That way, at least you're mitigating that much pressure from getting into the building. Sealed decks might be a little bit harder than doing that, so you may have to use some kind of sheet good to basically seal it up, making sure that all that air pressure is then caught inside the building and doesn't move into the system itself. So outside airflow must be sealed, so you don't have any kind of problems. Sealing cavity walls in the interior and sealing the deck and penetrations are very important. Now, standing seam metal roofs or metal roofs around here are very popular. So this is some of the things that we've been seeing. There are a lot of different configurations of metal roofs and how they're used, from corrugation to fluted. Problem with corrugation is that I've had people actually try to install mechanically fastened systems directly over these things, And what happens is in the canopy fastening system, the fasteners are designed to go perpendicular into the metal deck. When you have a curvature, you're not getting a circle, you're getting an oval, and the fastener is not working properly. And you could actually have a ratcheting effect where the fasteners will slowly back up. So it's not a long-term performance that's going to happen. You're going to have a very weak system long-term wise. Other systems with the flutes, typically what we do is we fill them up with insulation, and then we put the system over the top of it. And manufacturers make these bevel cut products to be able to fit into them properly. When you're looking at fastener engagements, typically if you're trying to go right into the pan, they're usually 26 or 24 gauge, so they're very thin. Using a number 15 fastener, you typically only get the 300 to 400 pound pull values out of the weaker materials. And these materials are not tested in laboratories. They could if they wanted to. There's actually a protocol within the design criteria for doing that, but manufacturers don't do that because they know it's going to fail. So they don't do it. This is the mathematical calculations in determining the uplift performance. So if you have the wind resistant characteristics from the ASCE 7, you can then do a comparison. This was around a 400 pound pole, 6.5 feet, fastened at 6 inches on center. It only comes out to 61 pounds per square foot. So it's a weak system comparatively, and you may need to do additional enhancements in the perimeters and corners. And it even gets weaker with a lower pull-out value of 300. So keep that in mind that these decks, though they will accept the fasteners, they need to be looked at very closely to be able to confirm you're meeting the pressures necessary to withstand and be resilient. Most of the designs that are offered are fastening into the purlins, and the purlin fastener engagement is very, very strong comparatively, where you're getting from a 600 pound pole to a 100 pound pole, and those calculations or those fastenings comes out to a very significant performance characteristic of 200 pounds per square foot. So fastening into the structure versus the metal pan is going to give you the long-term performance, thank you, that you want out of that system. And there are other types of systems to help make it even more convenient. There are these induction welded systems where you can fasten the plates into the purlins and then heat weld the membrane directly to it. So you don't have to have custom made sheets. You can just use whatever manufacturer offers, very large ones, and you just have to heat weld the seams accordingly. And there are specifications on how to lay out the plates for perimeter areas. They're usually what we refer to as fingers coming in the edges, and then give you an idea of how to make that actually a very aesthetically looking type of design. Now there is a third way of doing it, and you could do adhered systems to it, where we're actually going to be fastening in the insulation to the deck metal pan. Calculated wise, it does come out reasonable between 75 and 100 pounds per square foot, and then you can adhere the membrane. So you fill the flutes, put your insulation or cover board, fasten it down, and then put the membrane down and adhesive. Then there's also ribbon type of applications, the 2-part urethane adhesives, where you can actually do a serpentine pattern in the pan and flute, fill up the insulation, then continue the insulation with a cover border, and then you can put down your membrane system. No fasteners are used at that point. Insulation adhesives sort of leads us into this because we want to make sure that we have correct surfaces to apply the 2-part urethane adhesive. This is a cementitious wood fiber, but it was uneven, so the boards were not getting good engagement with the adhesive, and they were gotten weakened attachment. Concrete is supposed to be smooth, not looking very rough and uneven also. So those are surfaces that we do not want to try to use adhesives to. And then in re-roofing applications where you have a modified or a built-up roof, look at the surface of it, see what kind of condition the existing BUR is. If you're looking at questionable, we found that priming it with a primer prior to using the 2-part urethane adhesives, you get much better significant performance. So for instance, non-primed is only 60 pounds per square foot. priming, we got 540 pounds per square foot. So significant better performance for a long-term system. And then application concerns. Don't wait so long to make sure you put the boards in. There is a time limit, they need to be followed. Letting it cure out completely, the boards will not stick. Making sure we have enough even coverage of the adhesive. Using half the amount of adhesive is not going to give you half the performance, it's going to give you far less than that. People have asked us, well, you guys are manufacturers, you always put belt and suspenders into your designs that you're specifying for us to put down. That was true 30 years ago. The industry has gotten extremely competitive. There is no more belt and suspenders that any manufacturer uses within their specifications. You have to follow what we write and the coverage rates to make sure that the system goes down properly and will stay in place. This is a chance to show that ribbon width is very important. We specify that. It needs to be followed. By putting in just a thin pencil line, you're not going to get a long-term performance. Basically say maximum spacing 12 inches on center. This one is definitely much larger than that and shouldn't be used. These are the patterns that are typically would see between 12, 6, and 4. There are other kinds of odd ones that could be used depending upon whose standard you're following. And these are some of the things that you need to keep in mind when you're trying to install the roof properly. Bonding adhesive coverage rate is also important. Typically application, we see that using roller type of products with solvents, and there's also cylinder type of applications where they can spray it down. They let it sit for a minute so you get the correct tackiness, and then they put the two products together. This is a very advanced technology application system where we take the can of adhesive, we mix it up, we put it on its side, we punch a bunch of holes on the side of it, it then drips onto a piece of carpeting, and you pull this behind you. Now, as simple as that sounds, the adhesive comes out real fast to begin with, so the applicator has to sort of move fairly quickly. But then again, when the adhesive starts to slow up, that adhesive then gets thinner and thinner. So they need to back roll this, they can't just rely upon it. This one was actually that type of application where they ended up having very poor application, and the wind took it and started taking the roof off. They reported that this is being 50%. I don't know if I think it's a lot less than that, but this is what we can see, and it's not gonna last. It doesn't take much wind to actually start to make that fall off. And then making sure, even with roller application, this one they only put adhesive on one side. So they put it on the membrane and then try to roll it onto the substrate, and nothing stuck. It just basically came off. So these are some key pieces to consider. Specify back rolling when you see that particular product being used. Avoid porous type substrate materials and VOC materials, which is very popular in the States. Maybe needed more time for flash off if it's been specified down here. Some of the advanced technologies, if you don't want to even deal with adhesives, is this hook and loop kind of product. And they sort of reference it as being a Velcro, where the substrate actually has the hooks, and the loops are in hooks are in the facer, and the loops are in the membrane, and you basically fasten this down or adhere it down, and then you go ahead and roller the special membrane into this, and then you get very, very good performance. No adhesives. This works really nice on operating buildings where a building owner is concerned about smells. If it's a hospital, those kind of configurations where you may need to avoid those things. And so no adhesives, no odor, no temperature restrictions, and no waiting for adhesives to flash off. Last section, sheathing boards. This is sort of something that I've been seeing used in quite a bit, where they're using the sheeting board that's on the exterior for, say, siding or the wall, and then they come on the back of the parapet and they use the same board. This was a study that was actually done and was presented at RCI back then, now IBAC, where they had glass face or sheathing boards, and they were having problems with them. And the problems that they were seeing, installers were reporting noticing unexpected performance for exterior air barriers and vapor retardants. Basically, the product was coming free. And they were trying to do all this analysis to determine what was causing that problem. So they started to look at it very closely, and they verified that all the boards meet the ASTM criteria for each of the boards. But the facers were what they eventually boiled down to, and found out that there were some issues associated to actually application of the adhesives or primers, and then there was a problem, and they were trying to continue to do that. So they went to even a farther study with it, and they started looking at some of the sheet goods versus its under magnification of 50 times, and they went as far as 100 times to see what might be the difference in those products causing that application issues. Just to give you an idea what they were looking at, this is sample A, and this is what they refer to as the fiber matrix, which is all those kind of fibers that you slightly see in there. And then they have the chemical matrix, which is all the stuff that they put in it to glue or cover that all together. And that's how they make a sheet of a facer for a product. Sample B, you see a lot of chemical matrix, and you don't see much fiber at all. Sample C, you see a lot of fibers, no chemical matrix almost. So that's the kind of differences they started to actually notice during this investigation, that these products were significantly different. Now, what they did is they went under 100 times magnification, and they applied adhesives and primer to each one of these samples. Sample A, here's the matrix again, and I don't think the pointer works on this, no. But you can see this is how deep the adhesive was going, or the primer. So it was soaking up quite a bit of the product, not leaving anything on its surface for any kind of additional products to be attached to. This one was a little bit better. It showed some significant soaking going on, but it stayed pretty much to the top. This last one, couldn't even find it. It just soaked all the way through. There was nothing for the product to adhere to. So what they found out is that to use these specific products, you'd have to know how much adhesive or primers that you would have to use, and that would fall on the manufacturer to verify how much would be necessary to make sure sheet goods stay applied to it. Now, for roofing material on the back of the parapets, even though we've been seeing this, we've always stated to use roofing boards, the same boards that we used on the surface of the roof system to adhere to, and we've tested in the laboratory. Those boards should be used on the parapet wall. If you see a sheathing board that's used for the exterior, on the interior, that board needs to be overlaid. So it's very important, because the flashing will eventually fall off. We have actually seen that this kind of porous substrates, you're looking at 30 to 50% more adhesives or primers to be used to have a chance of making sure those products stick to the wall. So it can be significantly more products and costs that were not estimated or bid for the job. So those are very important factors to make sure that you get a long-term performance and the roof system doesn't have any problems. Any questions?